Hi, good morning, everyone. Good morning, friends. It's a marathon webinars we've been having in most of the weekends. Well, warm welcome to all of you. Good participant today. We have almost 425 registrant from India and abroad. So today is our 199th webinar in just 2 years. And today's topic we are discussing is very, very important, which is impacting simple reliability and compliance in every building, every home, and every industry. So today's focus is mistakes in cable termination and entry cost lives, understanding the National Electoral Code of India 2023's requirement. So why this is important? Why we are touching upon this subject today? Because over 60% of electrical accidents originate from improper cable termination or entry points. When you after finishing this webinar, just have a look at your distribution board. Just check whether your distribution board has a professional terminations. So the loose or incorrect termination lead overheating, arcing, and major fire incident. That's the reason major fire accident happen just because of poor termination. Most cable failure in industrial plants, hospital, airports, and data centers are because of small installation errors that go unnoticed. The NEC 2023 has introduced critical changes in termination practices, conductor sizing, entry sealing, and fall protection. Understanding these changes is essential for every contractor, every electricians, consultant, and facility team. And most importantly, correct cable termination saves lives, prevent downtime, and ensure compliance with global standards. So today we have a fantastic speaker, Krish Board, complimented by Nehal Gandhi. So on behalf of NFE, National Federation of Engineers, India, National Federation of Engineers for Electrical Safety, I thank each one of you for joining today's webinar. So my request is to all the participants, let your question be very specific to today's topic. And your question should be only in Q&A box. Do not put your questions in chat box. Chat box will not be noticed. So I request humbly, please post your question answer only in Q&A box that you'll find below your screen. NFE is a crusader. It's a non-stop knowledge sharing which is happening across the country. We have concluded 55 physical seminars in the country in last 2 years. In 30 months, I would say. Over 200 webinars. When you compare the 9 hours spent on doing this webinars and the seminars, it's huge. That's why you call NFA is one of the fastest growing society in India, fastest growing engineering society in India. So we are here to create and fighting for today's for better tomorrow. We are we are getting our younger generation equipped with the better practices. So what we do in NFE, make every electrical installation free from accident, such as electrocution and fire into short circuit. Mission, we will focus on electrical safety by design, manufacturing, accreditation, and certification. So we have, few membership titles. We have individual membership, we have corporate membership, we have MSME membership. When you visit our website, you'll find join NFE on the right. So it just take less than a minute for you to become member of NFE. It costs you only 1,000 rupees in a year. that is much larger than any university, any MBAs that you study. The kind of knowledge that you get, the kind of network that you can get from those members is huge. Like 1,000 rupees or a corporate, you want to network with consultant, influencer, corporate is the best uh, membership title that you can have. So I urge all the participants who are here today, request you to please go through our website and become a member. So myself, I'm Dominic. I'm in the fire industry for 36 years and actively taking part in NFE, in organizing various events, webinars. So my passion is business development, marketing, and events. So I'm a founder of FSA, Fire and Security of India, Focus, and NFE. With me today's speaker, the highlight of today's topic speaker is Krish Theobald. He's an expert in electrical safety and installation standards, which specializes in protection against electrical shock, overcurrent, wiring system, and verification of installations. He is an active member of multiple BIS committees, including those responsible for the National Electrical Code of India and NBC, National Building Code 2025. Internationally, he represents India in IEC committees on electrical installation covering conductor capacity, disconnection time, verification, safety and local energy generation storage. He also proposed and developed research in short circuit current in low voltage DC systems. Krish also developed a software which is complemented the existing software to include the design, electrical circuit design as per the NEC 2023. Last week we had the webinar on how to design effectively the electrical circuit in a building. Using this software, you will eliminate wrong design. So, and also selections of right cable, right terminations. So that is not mentioned in this profile, but Krish is one of the member who was part of this design software. So Krish has trained over 5,000 engineers through various workshops and guest lectures, authored many technical articles, and has been featured in industry podcasts and publication. As I said earlier, is a member of BIS ETD 20 and ETD 32, CD 46 Part 13, and working group IEC 64, MT1, MT2, MT9, MT12. He is one of the most sought after speakers on the various rules and codes in India. He's been traveling with us throughout the country. I think over 73,000 people have attended our workshops and webinars. And Krish Theobald is not new to the industry. He's one of the familiar face for all electrical professionals. We have our guest speaker, Nihal Gandhi. Is a founder of A1 Electrical, bringing 25 years of expertise in the electrical and cable accessories industry. Began his career as a sales executive in Rajkot. His passion for electrical solutions led him to establish Fitwell Technology Private Limited in 1998 in collaboration with KHEC Malaysia and DSG Kanusa, Germany, pioneering heat shrinking termination and joint manufacturing in the region. Since founding of A1 Electrical in 2006, Mr. Gandhi has transformed the company into a trusted global supplier of precision engineered metal component for cables and electrical infrastructures. His leadership focuses on innovation, technical excellence, and commitment to quality, which has established his company to serve customers across India, Middle East, Europe, and emerging global market. Recognized for his strong industrial insight and customer-centric approach, Mr. Gandhi continues to drive A1 Electricals towards growth, advanced engineering capability, and international expansion. With this, my introduction over, and I would like to welcome our speaker, Mr. Krish Theobald, to take over from here. Thank you.
Good morning, everybody. So,
Good
as you are
morning,
well
Krish.
aware of the format of our webinars, we will keep it very technical. So, feel free to put your questions. Just make sure you put your questions in the chat box, not in the chat box, but in the Q&A, because in the chat box they can get lost. I will scan through the chat box later on in case something has been missed, but I'll keep a point to. I'll keep a point to only look at the Q&A throughout the session. So I'll just share my screen, and here it is. So let's start from the very beginning. This screen with my mouse is visible, right? Cable accessories for compliance with
Yes,
NEC 2023.
yes,
Okay.
yes, yes.
So, like I said, we're talking about cable accessories, particularly lugs, cleats, and glands. So, it's a deep dive into the requirements for cable accessories according to the requirements in the National Electrical Code of India. Of course, the presenter is me, so you all know very well. When we talk about this subject, just to break it down for everybody, we'll first look at what are the applicable laws, regulations, and standards in India for this particular domain. What are the specific requirements in NEC 2023? What is the current market practice that's being followed? And then, of course, what products are there to facilitate compliance? Because, throughout the several webinars and in-person training that we've conducted, something that's often asked is, okay, you're telling us what's written in the standard, but how do we actually achieve conformity to these clauses or these requirements? So the purpose of this webinar today is just to explain to you what products are there to facilitate compliance and how they are to be used. And of course, we're always open for questions. The regulatory framework for electrical safety in India is something that we should all familiarize ourselves with. And I think some of you are already quite familiar with, but this is what it is basically. We have the Electricity Act 2003. This is enacted by the Parliament. And this act establishes that there is a body called the Central Electricity Authority, and this body is allowed to make regulations for various purposes, one of them being electrical safety, so protection of people and property. And these regulations then mandate the use of standards. So a regulation is a broad overview of what has to be done, what are the requirements to follow the act, and the installation standards are the practical requirements to comply with the regulations. And of course, installation standards are only how do you integrate things, but individual products, that is based on product standards. So in India, the Electricity Act is enacted by the Parliament. The CEA is a separate body, statutory body. The installation standards are written by the Bureau of Indian Standards, which are largely adopted from IEC standards. And for product standards, there are some Indian standards and some IEC standards. The Electricity Act 2003 lays out very specific penalties for non-compliance. So, for example, in Part 14, Section 146, we see that whoever fails to comply with this act or any provisions of the act or rules or regulations made thereunder, they are going to be punishable with imprisonment and fines. So that is what it is. Yeah. Um, Particularly in section 149 of part 14, it says that where this offense is committed by a company, every person at the time of this offense was committed and who was in charge and was responsible for the company and the conduct of his business is liable. They shall be liable and be proceeded against and punished accordingly. And this may be due to neglect and of any director, manager, secretary, or other officer of the company, and they can be proceeded against as well. This is very important because in organizations when electrical safety is a concern or when electrical installations are being done, it's not just the electricians that are going to be held responsible. The management has to make sure that the electrical installations are safe because if there is a non-compliance, it is them who can be punished and proceeded against. So it's very important on that level that the standards are correctly followed. what are the relevant installation standards in India? We have the National Electrical Code of India, of course, which you all are familiar with, and the very important IS 732. This is a crucial document because it is an adoption of the IEC 60364 series. It's a very structured document that tells you how to conform to the requirements for safety. I am audible loud and clear. Just want to check in because I know in the beginning there were some concerns in the chat. So, am I audible loud and clear?
Yes, Krish, you're audible.
Can he be a bit louder? Amritlal is saying. Okay, I will try. Okay. So, what are the relevant product standards? So, for our subject, there are so many product standards, but today specifically, I want to focus on three product standards. That is IEC 61238, the 61238, 61914, and 62444. So when it comes to these standards, this is the standard for lugs, this is the standard for cleats, and this is the standard for glands. We'll start with glands today. So a cable gland, according to its standard, is defined as, and by the way, every standard of mine, just like every presentation of mine, just like always, has a reference on top. So you don't have to take what I'm saying at face value. We're not here to sell you anything. We're not here to give you a narrative. You can verify everything in your standard, right? So every slide will have a reference to a particular standard and a particular clause. So this is in, you go to 62444, you'll find in 3.1 this definition is there. So cable gland is a device which is designed to permit the entry of a cable, flexible cable or insulated conductor into an enclosure and which provides sealing and retention. So sealing and retention are very crucial. It may also provide other functions, for example, earthing, bonding, insulation, cable guarding, strain relief, or a combination of these. So it is required to provide sealing and retention, but as you will see, there are there are a wide variety of glands, and there are important functions such as earthing, bonding, and insulation, of course, and all of these functions that come into picture. We're going to be focusing quite a bit on earthing and bonding as part of this webinar as well, because I know that there's a lot of interest in these subjects amongst our participants. So we've got about 150 people who are online right now. So terminations of cables. So IS 732 2019 clause 5.2.9 says that in dot 5, conductor connections, so not only final conductors but intermediary connections as well, shall, now we know that shall is a requirement, be made in suitable enclosures, for example, connection boxes, outlet boxes, or in equipment if the manufacturer has provided space for this purpose. In this case, equipment shall be used where fixed connection devices are provided or provision has been made for the installation of these connection devices. Importantly, at the termination of final circuits, conductor shall be terminated at enclosures. Extremely important because when a cable enters an enclosure, this termination has to be made in a correct manner. What is this correct manner? There's further information provided. Cores of sheathed cable. So sheath cable is, for example, a multi-core cable. There's insulation on the individual copper or aluminum conductors, and it's an overall oversheath. There's a sheath that goes on top. The cores of sheathed cable from which the sheath has been removed and non-sheath cable. So, for example, just single core cables, which are non-sheath, at the termination of conduit ducting or trunking shall be enclosed as required by 5.2.9.5. So when a cable enters an enclosure, it has to be correctly enclosed. Now you may ask me, Krish, what does correctly mean? And you say that's a very valid question. That depends on what rating of IP rating is required. What is the IP rating required? We'll go into this in further detail. You can see in these images, this is a gland and this is a gland entering a piece of equipment with a shroud on top. So this particular is, I believe, an IP66 connection or IP68 as it may be. Further requirements are provided here. Connections between conductors and between conductors and other equipment shall provide, of course, durable electrical continuity, very important, adequate mechanical strength and protection. So this electrical continuity, of course, applies for live conductors, but it also applies for protective conductors. These may be protective earthing conductors or protective bonding conductors. Connections and junction points of cables and conductors shall be relieved from mechanical stress Strain relief devices shall be designed as to avoid any mechanical damage to the cable or conductors. This is, of course, extremely important because when you have a cable that enters an enclosure, that cable may have a significant length, and this may be subject to significant mechanical damage. So it's very important that the cable is protected against provided with strain relief, because any strain on that cable should not be affecting the terminals. That's very important. Sorry, I don't know what happened there. Uh, Connections and junction points of cables and conductors shall be reached from mechanical stress. I'm repeating, it's not only the connections and the junction points that have to be made correctly, they have to be relieved from stress as well, because any stress on the cable will end up providing stress on the terminations. That's why we saw earlier that glands provide strain relief. Where a connection is made in an enclosure, the enclosure shall provide adequate mechanical protection and protection against the relevant external influence. So you'll see this word coming up a lot. This is external influences. If I zoom into the image here, you can see this is a very, very standard arrangement in India. We have an armored cable entering a piece of equipment. And firstly, there is ingress of water, dust, etc., and this has not been sealed. The armor is also just lying there. So we are not having any adequate mechanical strength. There's no mechanical strength. There's no strain relief. There's no protection against external influences. If we look at this particular thing, this is even worse. We just have holes and we have equipment, we have conductors entering through these holes. So no ingress protection, no strain relief, no continuity on the armor, absolutely nothing. These are complete violations of the standard, and as we know, these are punishable. When we talk about IP ratings, that's very important. Um, Live parts shall be inside enclosures or behind barriers providing at least the degree of protection of IPXXB or IP2X. What are these? I will explain. Basically, if you have any live part inside an enclosure, this is the minimum degree of protection. There are far more stringent requirements for horizontal top surface, the top of an enclosure, for example. The horizontal top surface of a barrier or enclosure which are readily accessible, shall provide at least IPXXD or IP4X. Now, what does this mean? See, IP2X means that you're providing protection against ingress by a finger, so nobody can go and touch it. So, for example, if you have something that is an object by 12 millimeter diameter and 80 mm length, it should not be able to ingress. And any solid foreign body greater than 12.5 millimeters in diameter should not be able to ingress. IPXXB is specifically for protection against finger. IP2X is also for the solid foreign body. So IP2X is 12.5 millimeters diameter plus 12-meter diameter finger. IPXXB is only the 12.5 millimeter, 12 millimeter diameter finger. Now, the important part is the horizontal top surface, right? So that is this horizontal top surface here, for example. If I just scroll in, I'll just show you. This is a horizontal top surface that we have right here. I'll just highlight it with a pen. Yeah. For horizontal top surfaces, the requirement is IPXXD or IP4X. Now, IPXXD means that protection against access by a wire. So 1 millimeter diameter wire that is 100 millimeters in length should not be able to penetrate this object. And any solid foreign body with a diameter greater than 1 millimeter should not be able to penetrate. Now, clearly, if we go back to our image, you can see that this is far bigger than 1 millimeter. This is a complete violation of the standard. So this is a problem. And these requirements are additional to the requirements that apply for protection against ingress according to the relevant external influences. This is a requirement that applies everywhere. So regardless of how much water is there, how much dust, there is absolutely no water, no dust in the place, completely sterile environment. Still, we need this requirement, right? IP2X or IPXXD or IP4X and IPXXD, depending on what we have, horizontal top surface or anything else. Wiring systems shall be selected and erected so that no damage is caused by the condensation or ingress of water. Very important. The completed wiring system shall comply with the IP degree of protection relevant to the particular location. So every location should be studied on a case by case basis, and I'll show you where in the standard you can figure this out. What is your particular case, and we need to figure out what is the level of IP protection required. And importantly, wiring systems shall be selected and erected so as to minimize the danger arising from the ingress of solid foreign bodies. So we don't want dust to enter, for example. The completed wiring system shall comply with the IP degree of protection relevant to the particular location. So again, this is the minimum. In a completely sterile environment, also this is required. However, in most cases, particularly in India, we have a lot of dust and a lot of water. So these two requirements are relevant to the type of external influences. Now, what are these protection against external influences? See, the installation method selected shall be such that protection against the expected external influences is ensured in all appropriate parts. So it doesn't just apply for the where the cables are and where the cables enter the enclosure. Anytime you have any conductors or support anything part of the wiring system, it is required. Particular care should be taken where there is change in direction and where wiring enters an equipment. For example, it is very common in many discom premises to see installations like this, where they've just chopped out the bottom, you know, and worse, they have used a steel. This thing is entirely corroded as well, and now you have firstly you have complete somebody can go and touch this bus bar and they can die. So there is no protection against electric shock and there is no protection against ingress of water or solid foreign bodies. This is complete non-compliance. Yeah, and now when we talk about external influences, they are categorized in table 7 of IS 732. So you see, you go to table 7 here, for example, presence of water. Negligible presence of water means AD1. So IPX0. Free falling water means IPX1 or IP2X. If there are sprays, then IPX3. If there are splashes, then IPX4. If there are jets, then IPX5. If there are waves, then IPX6. If there is immersion, for example, it may something that may be flooded for some amount of time, then that is the case. If it is entirely designed to be submerged and the pressure is greater than 10 kilopascals, then it's IPX8. So very important, you need to understand what the relevant external influences is. See, in India, we have a problem that people just put the same equipment everywhere, and when it is installed, it is not installed correctly. But also, like Mr. Gandhi was telling me earlier, we also have a habit to over-specify sometimes, where we put IP68 everywhere, which is also completely not required. So we need to study it by a case-by-case basis. For example, last week I was in a hotel somewhere, and inside the bathroom, there was the IP66 socket. Firstly, the socket should not be inside the bathroom, and then it was in a dry area, and then why was there a IP66 socket there, god knows. So very funny things that we have happening. Over specification is a problem, and using the same product everywhere is also a problem. Yeah. Now, yeah, as somebody mentioned in the chat, all the provisions are as per IS 732. Presence of dust is also there. Negligible dust, small objects. You have to read the standard and figure out what is your relevant level of external influences, and accordingly you have to select the level of ingress protection required. But no matter what, the basic requirements are always IPXXB or IP2X, and horizontal surfaces IPXXD or IP4X. Anything beyond this according to the external influences, which in most cases will be there. Now, what do these numbers mean? See, the first characteristic numeral in a IP a number or IP alphanumeric code indicates two things: protection against access to hazardous parts and protection against ingress of solid foreign objects. So, when we say IP2X, it means that it's protected against access to hazardous parts with a finger, and the test is performed with a test finger of 12 diameter by 80 length, and there is required to be adequate clearance from any live parts. If it's IP4X, then it is, or just IP4, the first characteristic numeral is 4. Protection against access to hazardous parts with a wire. Now we're talking about an access probe of 1 millimeter diameter. Yeah. So if it's 2, it is this. If it is 4, it is this. It also means that there is no ingress of solid foreign objects greater than 12.5 diameter or greater. A probe of a sphere with a sphere of 12.5 diameter cannot penetrate. And if it is 4, then a protected against solid foreign objects of 1 diameter. So an object probe of 1 diameter cannot penetrate at all. Very important, right? The first characteristic numeral identifies both of these. So if it's IP2X, finger is protected and solid foreign object greater than 12.5 millimeter. If it's IP4X or IP just IP4, protected against access with hazardous parts with a wire, and one object with greater than 1 mm diameter cannot penetrate. So this is the first characteristic numeral. The second characteristic numeral designates protection against ingress of water. So what are these? Now there are different types, as we know. 0 means not protected. 1 means protected against vertically falling drops. This is the second alphabet. So IPX1, IPX2, whatever. X just means it could be anything else. Or not particularly, it means not verified. But so it could be, for example, if it is IP 44, or say for example IP 42, the first alphabet will be 4. So this 4 and this 4 apply, and the next alphabet will be 2. So it is this one that applies, for example. Protected against vertically falling drops, water drops, when an enclosure is tilted up to 15 degrees. Protected against spraying water is 3, 4 is protected against splashing water, 5 is jets, 6 is powerful water jets, 7 is effects of temporary immersion, and 8 is effects of continuous immersion. Important thing is, when there is a certain characteristic numeral designated, all the lower ones are also considered as satisfied for the first characteristic numeral. So protection against ingress of solid foreign objects and access to hazardous parts. But for the second characteristic numeral, up to 6, it means that all the previous are taken into account. After 7, it is different. It needs to be verified on a case by case basis. There are also additional letters when we have IP. For example, the additional letter may be A, B, C, or D. So for example, IPXXB or IPXXD, like we spoke about. These are used in some specific situations. For example, the first situation is if the degree of protection against access to hazardous life parts is higher than indicated by the first characteristic numeral for ingress of solid foreign objects. So you provide a greater degree of protection to against access to hazardous parts, then you provide for ingress of solid foreign bodies, then you can use this. Or if there is no protection against ingress of solid foreign bodies, or it's not specified, then it is there. So IPXXB means that there is no it is not declared for ingress of protection against solid foreign bodies, but it is declared for protection against access to the finger. IPXXD means it is not declared for protection against access to solid foreign bodies or water, as a matter of fact, but it is there for protection against access by a wire. Just a little bit about this terminology. There is even one more letter, a supplementary letter, but we will not go into it in too much detail right now. The idea is just to give you an overview of what these letters mean. And it is a misconception that IP means ingress protection. This is not true. IP means international protection. Why? Because IP not only provides protection against ingress of solid foreign bodies and water, it also provides protection against access to humans to hazardous life parts. So it is very clearly international protection. That is what it means. Yeah. Now, so somebody asked, what is the B and D in the IPXXB and IPXXD? This is what the B and the D mean. Yeah. Again, all of this is in the standard. This particularly is in IEC 60529. When we talk about glands and glands that are providing this IP rating, what does it mean? If the gland conforms to IEC 62444, they are required to be classified according to their IP code, and the minimum is IP54. So what does that mean? Protection against access to hazardous part with a wire. So an access probe of 1 millimeter shall not penetrate, and it is entirely dust protected. So ingress of dust is not totally prevented, but dust shall not penetrate in a quantity to interfere with satisfactory operation of the apparatus or to impair safety. So if you select a gland according to IEC 62444, it has to meet this requirement as per its product standard. Yeah. Now, IP5, first letter is 5, second letter is 4. Protection against splashing water. So any water that is splashed against the enclosure from any direction shall have no harmful effects. Again, remember the third letter is optional, so there's no third letter, so it's just IP54. Type designations. Now, this Mr. Gandhi was telling me about this a little bit in detail, so I thought we'll include it. See, basically, every gland that we get in the market, it needs to conform to product standard. Now we have IEC 62444. Earlier, especially when there was a lot of influx of British products, there was a very old British standard. This is in the 80s. There was a standard called BS 6121, Part 1. And there was some legacy codes that were assigned. For example, but we still use these codes today. It's very colloquial, which is why I'm referring to it again and again. For example, BW, CW, A1, A2, A3, A4, E1W, right? What do these mean? So I'll just go over this and explain to you. It's not always necessary to choose the most extreme type. Again, these are legacy, so you need to look at what the product is conforming to. Important thing really is your 60529. Yeah. So BW, CW, A1, A2, A1, A2, A3, A4, E1W. These are legacy codes. So BW meant that it is an armor gland as specified in this standard, and it is designed for single steel wire armored cable. This is an example of a BW gland. CW gland means it is a cable gland with a seal to an outer cable sheath providing an ingress protection of IP66. And it is designed for providing cable retention with the armored cable. The W means it is suitable for single steel wired armored cable. E1W means the cable gland which provides seal to the inner and outer sheath, giving an ingress protection of IP66 and cable retention. W means it is suitable for single steel wired armor. So you can see that there are other alphabets also for wire braided cable, aluminum strip armor, double steel tape armor, so on and so forth. A2 means a product that is just a basic gland which provides ingress protection. It's just for unarmored cables. Now, this is a little bit about the ingress protection. Now, a subject of quite a lot of interest amongst people is the aspect of earthing, right? So, what is this? See, we all know that the protective measure of automatic disconnection of supply is the most common for electrical installations that are low voltage. There's basic protection, fault protection, and additional protection. Crucially, fault protection is provided by protective earthing, protective equipotential bonding, and automatic disconnection in case of fault. Today, I want to focus a little bit about protective earthing and automatic disconnection in case of a fault. Protective earthing and protective conductors have requirements. Firstly, each circuit shall have available a protective conductor, and this has to be connected to the relevant earthing terminal. And protective conductors shall be suitably protected against mechanical damage, chemical or electrochemical deterioration, electrodynamic forces, and thermodynamic forces. Remember this mechanical damage and electrochemical, we'll come back to it. Every connection, for example, screwed connections, clamp connections between protective conductors or between a protective conductor and other equipment shall provide durable electrical continuity and adequate mechanical strength and protection. Screws for connecting protective conductors shall not serve any other purpose. So, very important that mechanical damage is protected against and there's adequate electrical continuity and mechanical strength. Remember, this electrochemical aspect, will come back to it. When we want to disconnect, there's a very crucial requirement for automatic disconnection of supply. This is the earth fault loop impedance. So the earth fault loop impedance shall be lesser than or equal to UO divided by IA. So this needs to be kept to a minimum. In India, we also add in a further 2/3 safety factor. Unfortunately, we forget that resistance, this is just on paper. To actually achieve this requirement, we need proper electrical continuity, not just for live conductors, also for our protective conductors. And the most common protective conductor that is there everywhere, but it's not being correctly used, is the armor. So you can see here, this is the armor. The armor has just been taped over, and somebody has pulled out a steel wire. Completely inadequate arrangement that we have here. None of these requirements are being met. There's no protection against mechanical damage, no protection against no electrical continuity, no mechanical strength, and of course, all the requirements for ingress protection are just outside the window. Also, it is extremely unsafe because people can touch it, it can come loose, it's very dangerous. When you use a proper armored cable gland, there is a clamping ring and a tapered cone, and all of this goes inside the gland. So there is proper mechanical protection and electrical continuity ensured. If you actually do a test on the armor like this, it is providing far enough electrical continuity. I'll show you also what test the glands are actually subject to. See, when we use a steel wired armored cable gland, we have a continuous protective conductor running. So we are able to have a TN system. The impedance of the protective conductor consists of the steel wire armor and the gland itself. So there is enough. If the insulation is designed correctly, enough earth fault current will flow. Automatic disconnection of supply will be very effective, right? Now, and why is important? Because the earth fault current is always the nominal voltage to divided by this impedance, and this is a crucial part. But in India, oftentimes we see that this is not being done. Very common arrangement is that we will bring in a armored cable from the bottom of the panel, and of course, in typical fashion, there will be garbage that is stuffed there. This will be taped over, the armor will be taped over, and the cable will be brought in. You can see there's absolutely no protection against ingress of dust or anything that is over here. And on the side, there is a GI strip that comes inside. Now, what are the problems with this? There are several problems, but I'm going to focus on the problems relevant to the requirements we saw now. First problem comes, the path of the protective conductor is now entirely different from the path of the line conductors. So the impedance of the protective conductor is particularly high. Normally, when we say ZP would be the impedance of the protective conductor consisting of steel wire armor, and this no longer applies. This ZP will have a very high reactive component as well due to the spacing with the actual line conductors. Additionally, we have a big inductive loop that is creating, and it is particularly harmful in terms of electromagnetic interference. Lastly, GI strip itself does not have a particular resistance value, and there is no proper way to make a joint there that is standardized. So it is particularly dangerous and much more expensive. You have to buy all this GI in addition to the armor that you're already buying anyways, which comes as part of the cable. Furthermore, when you enter a cable from the bottom and a GI strip from the side, you're violating a requirement in the standard which says that conductors of AC circuits installed in ferromagnetic enclosures shall be arranged so that all conductors of each circuit, including the protective conductor of each circuit, are contained in the same enclosure. Where such conductors enter a ferrous enclosure, they shall be arranged such that conductors are only collectively surrounded by ferromagnetic materials. So they have to enter together. Whereas here, this is from the bottom, this is from the side, you have a bunch of ferrous material between. And this causes eddy currents and heating, which is not a good thing. That's why the standard is requiring that it is arranged in this manner. This is very important, yeah. So please keep this in mind. When you have sometimes an arrangement where there is no protective conductor that is installed at all, or the armor is just taped over and there's no GI, which we see sometimes, and we just have two electrodes. Now we have a relatively high impedance. This is like a TT system, and there's not enough fault current. We need to buy RCDs, which you will need type B for distribution circuits because you don't know what equipment are connected, and which is quite expensive again. There a simple solution would have been to to just use a gland and utilize the armor that you already have. And as part of the cable standard, the armor is required to be able to test it to carry the fault current as well, and the resistance is known. When you use a gland that conforms to IEC 62444 and is designed for steel wired armored cables, you see, firstly, you have a proper seal on the outside, and on the inside, you use this earth tag. You provide a lug, a nut, and a bolt, and you make a nice connection inside there. I have done this connection myself. It is particularly easy, and there's absolutely no problem in terms of the continuity. We get a very low earth fault loop impedance. The electrical properties in terms of the glands are also very rigorously tested. So, for example, equipotential bonding between the enclosure and the gland is tested, and this value has to be below zero point 0.1 ohm. Also, the bonding, the continuity between the armor of the cable and the gland is tested, and this has to be between 0.1 ohm. So the gland, the earth tag, everything is correctly tested according to this requirement if you choose a gland conforming to 62444. In terms of the ability to withstand fault current, the earth tag is very, very important. There are three categories: category A, category B, category C. So, like Mr. Gandhi is telling me, the A1 glands, they come under category C, which is that the armored cable can be used with a low sensitivity method of protection against fault current. So that means it may be, for example, an MCCB or an ACB. So very high amounts of fault current, right? They are, and particularly depending on the cable diameter, these are tested. And for example, a gland that is able to have a cable diameter of 8 to 11 mm. This is, for example, suitable for a simple 2.5 square mm multi-core cable, has to withstand 10 kA of fault current. So these glands have been sent to testing along with the earth tags for this level of fault current. And this is very, very, very important. So that is it about glands. So now I'll just move to the subject of compression and mechanical connectors. So, glands are very, very, very important for the subject of earthing, as you can see. And they are important for providing protection against ingress of solid foreign bodies, water, and of course, providing protection for humans to access life parts. When we talk about compression and mechanical connectors, there are three types. You know, there are actually many types, but there are three definitions that I want to talk about. A connector of a cable is a device for connecting a conductor to an equipment terminal or for connecting two or more conductors to each other. So the explanation is pretty self-explanatory. A through connector is a device for connecting two consecutive lengths of conductors together. And a terminal lug is a device to connect a cable conductor to other electrical equipment. Now, what are the factors affecting the means of this connection? How do you decide how do you want to connect? There are a bunch of factors. Firstly, the material of the conductor and its insulation. The material, obviously, we know copper, aluminum, whatever, that is important. The insulation affects the limiting temperatures, very important again. The number and shape of the wires, the individual wires which are forming the conductor. The cross-sectional area of the conductor, and the number of conductors to be connected together. So very, very, very important things. You can see this is a multi-core, three-core cable that is class 1 conductors. This is a three-core cable that is class 1 shaped conductors. This is a three-core cable with class 2 conductors. This is a three-core cable with class 2 shaped conductors. All of these factors affect how we can connect and what product we have to use to connect. When we talk about the number of wires forming the conductor, this is very important. The standard says that in order to protect against the separation or spreading of individual wires of multi-wire, fine wire, or very fine wire conductors, suitable terminals shall be used or the conductor end shall be suitably treated. Now, fine and very fine wires in accordance with IEC 60228, which is the standard for conductors, is very important here. See, there are class 1, which is solid, there is class 2, which is stranded, there is class 5, which is fine stranded, and class 6, which is very fine stranded. Terminals are marked. R means they are only suitable for rigid connectors. F means they are only suitable for flexible conductors. S means they are only suitable for solid conductors. Important. Spreading of fine wire conductors is a particular problem in box terminals. So, for example, when you have a class 2 conductor entering a box terminal, there is no significant spreading. So, there is pretty good electrical and mechanical strength, electrical continuity and mechanical strength. Class 5 conductors tend to spread quite a bit. Yeah, so this is a particular problem that we have in class 5 conductors when we enter a box terminal. Now, connections between conductors and between conductors and other equipment shall provide durable electrical continuity and adequate mechanical strength and protection. We already knew this. There's a note that says CIC 61200-52, which says crimped ferrules fitted to the conductors are a suitable means of terminating multi-stranded fine wire conductors, provided that care is taken to ensure all strands are inserted into the ferrule. So very important. The crimped ferrules should not be used as screwless terminals. For some examples, right, apart from box terminals, nut keeper terminals are very common, for example, on MCCBs and other contactors on spreader links, etc. So you have a copper conductor entering a terminal lug, which is a ring type on a nut keeper. We have an aluminum conductor entering a terminal lug, which is bimetallic, to ensure that there is no corrosion. What is this? I'll explain in a moment. Copper conductor entering a bootlace ferrule in a box terminal, aluminum conductor entering a similar lug in a box terminal. Now, when we talk about connections between dissimilar metals, the requirements are given in 5.2.5.5.2. Now, aluminum conductors are widespread in India, right? And terminals, the connections are often brass or copper. Dissimilar metals, these are metals that are different, are liable to initiate electrolytic action, and they shall not be placed in contact with each other unless special arrangements are made to avoid the consequence of such contact. This special arrangement, for example, may be this lug, which is a bimetallic lug that ensures there is no electrolytic corrosion. Lugs or connectors, which are mechanical compression connectors, are classified by two requirements. Class A are connectors that are subject to heat cycling tests as well as short circuit tests. So these are connectors intended for electricity distribution or industrial networks, in which case they can be subject to short circuits of relatively high impedance, a high intensity and duration. As a consequence, Class A connectors are suitable for the majority of applications. So this is what is there where there's a high short circuit intensity and duration, and the connector has to be able to withstand this. Very important subject, right? Okay. Class B is a connector that is subject only to heat cycling test. So it is a particular connector that is only subject to heat cycling tests, and they're only intended for really overloads or short circuits are cleared rapidly. So as you can imagine, the class A are subject to far more rigorous requirements. And of course, as Mr. Gandhi was telling me, A1's lugs, so just an example, they are all class A. So they meet this requirement of high intensity and duration. See, oftentimes we just go in the market and buy a lug. We don't really think about whether they are class A, class B, etc. Important considerations here. Crimping of lugs. So under crimped lugs are a big concern, as you can imagine. Here there is not enough crimping force that is applied. Over crimped lugs, you can see these two shears on the side that have formed. It's just copper is just sitting. Too much force has been applied. And correctly crimped, there is absolutely no air gap. It is a perfect seal. Yeah, this is the correctly crimped lug. Now, when it comes to crimping correctly, it's important to understand something to do with beyond the IC standards a little bit. There are these DIN standards. These DIN standards are present and they provide dimensions as well. Now, DIN 46235 provides a specification for cable lugs compression type with a cover plate, a ring type for copper conductors. DIN 46239 is cable lugs for compression connections, ring type for aluminum conductors. DIN 46267 Part 1 is a non-tension proof compression joint for copper conductors. DIN 46267 Part 2 is a non-tension proof compression joint for aluminum conductors. And DIN 46228 Part 1 is for bootless ferrules without insulation. DIN 46228 Part 4 is with the insulation. Now you may be asking me, Krish, you are in IC, you write the IC standards. Why are you talking about DIN standards? The reason is IC standards are written in a way so that they cover everything. So, for example, for the compression connectors, you have 61238-1-1 and -1-3. These are applicable, these are test methods for these products. But the actual dimensions are specified in these DIN standards. Why is that important? Because it has to do with the crimping. See, DIN 46235, for instance, provides all of these dimensions, and that allows for standardization with the crimping tools. If you go to a manufacturer, for example, and purchase a die set for DIN 46235, it is, and for example, this one is DIN 46235 and 46267 Part 1. This will be dimensionally compatible with the DIN lug. So you are ensured that you get a good electrical connection because the crimping is done correctly. So The IEC standards provide for safety, for example, for the requirements or the test requirements for that particular product. But beyond that, for crimping and to ensure a good connection, using a DIN cable lug is the way to go, because then you have dimensional compatibility between the between the lug and the actual compression, the crimping tool, which is very, very, very important. Why is this important? Well, we know that in India, most times there are no lugs that are used, and where they are used, they are often crimped, or I would not even use the word crimped, terminated in highly inadequate ways. There was another YouTube video that I was seeing where a guy asked a question. Uh, 25 for a 25 square mm, for a 6 square mm cable, what is the correct size of lug? I was thinking, what a ridiculous question. Obviously, it's 6 square millimeters. But he meant that you have to double up the conductor and smash it because it will get so badly deformed. So the correct answer was 25 square mm. And the guy gave away some Vivo mobile phone to the person that correctly guessed the answer. So unfortunately, we are in a situation where we are not correctly selecting uh, products, and in terms of crimping, we are not really using any correct tools. So buying a generic crimper is not really a good idea at all. The Oftentimes, when there is no lug used, for example, they are just twisted around and there is a nut and a washer and it is held in place. And here we have, for example, a plier has just applied force on this. You can see it's badly scratched up. It's not even crimped. And any little bit of force that you will apply, it will just come off the lug. Of course, here you have double door. This is particularly a bad condition. So, very important, select the correct type of lug. Make sure that it is relevant, the class is relevant for your application. And when you are using a crimping tool, the die and the lug have to be dimensionally compatible. Otherwise, there is no point. And again, these are requirements in IS 732, and we know that non-conformity to these requirements are punishable according to the CEA regulations and the Electricity Act. Cable cleats next are the uh, important subject. So when we have cables that are run, they have to be correctly supported and connected to their mounting surface. So cable cleat, according to its product standard, is a device provided with a means of attachment to a mounting surface, and that provides securing of cables when installed at intervals along the length of this cable. Importantly, the mounting surface doesn't have to be a smooth surface. It may, for example, be a cable ladder, a cable tray, or some strut as well. And the hardware like screw and bolts may or may not be specified depending upon the manufacturer. Yeah. Cables are to be supported, and so where conductors or cables are not supported continuously due to the method of installation, for example, a method of installation where it is continuously supported may, for example, be a tray, but they have to be, in a case of a tray, they have to be secured. They shall be supported by suitable means at appropriate intervals. In like, for example, sorry, just a moment. By appropriate intervals, yeah. Now, the crucial thing is these conductors and the cables should not suffer damage by their own weight or due to electrodynamic forces resulting from short circuit. Now, this is very, very, very important. One thing is supporting the cables, and make sure they don't collapse on their own weight. But the electrodynamic forces is a particular concern. I'll show you a video. When you have single core cables, particularly greater than 50 square mm, and a short circuit occurs, even for 0.1 second, which is enough time for a fuse to activate, there is a massive effect, an electrodynamic force that rips through these cables, and it can cause serious damage, and it can even badly injure or kill somebody. Here is a video that shows you what happens when no cleats are used or a cable tie is used and where cleats are used. It's just a generic video we've pulled out. can see again. This is without any cable cleats, because the cleats are supposed to withstand that short circuit current for a certain amount of time. But with the cleat, they are able to correctly withstand everything and stay in place. So it's very, very, very important. Just a second. I need to just switch because the video was there. Just 1 second, please. I will just reshare the screen. Slide. Okay, just resharing my screen in a moment. Is the screen visible? Is the correct screen visible, Lakshmi?
Yes, yes, it is visible.
Yeah. Now, we have seen what happens when cleats are not used and a short circuit occurs, right? And a short circuit that is interrupted. But in India, unfortunately, everywhere we see installations like this, where the cables are just dumped on the ladder or the cable tray. Spacing, forget about it. Over here, we see cables that are correctly installed and there are cleats that are there. Very important. This is a cable tray surface. So when a short circuit occurs, you can imagine what will the force that will just rip through this. Of particular concern is the single core cables with a metallic covering. When you have these cables, there's a question of whether to use a gland and connect the armoring on both sides or one side. But if you decide to do it on one side, there's a particular concern when they may move during a short circuit. So again, cleats are very important. Now, cleats, they are cleats that are according to the standard 61914, designed to withstand only one short circuit and designed to withstand more than one short circuit. This is tested as per a certain process. This is just a video to show you how these are tested. So make sure that the cleats that you are purchasing are designed to withstand more than one short circuit. So yeah, see, these are how the short circuit tests are being performed. So I believe Mr. Gandhi mentioned that the A1 product is suitable for much more than one short circuit. And as a classification according to the standard. So here they have tested. You can see the cleats are subject to a very high short circuit current. In this case, I believe it was, let's see how much, 100K, which is there for 0.226 seconds, which is a long amount of time in terms of a short circuit. And these are able to withstand that. And again, cable cleats are classified in two types that withstand only one short circuit and can withstand more than one. Please make sure the ones that you're selecting can withstand more than one, like the ones from A1. Now, you'll see that there are two types of cleats that are very common. One is for a single cable and one is for three cables. Single cable cleats are either used for multi-core cables or for three single core cables in a flat formation, or four as it may be. This allows for an increased current carrying capacity because there is no effect of grouping. However, there is a relatively high and imbalanced mutual inductance because one cable is, these are not symmetrical. When we talk about single core cables, the common arrangement is to arrange them in trefoil because each of the cores are spaced the same from each other. So there's very little mutual inductance. Also, it's equal, the reactance on each cable. So reduced inductive reactance. Now, okay, this is technical information for you, but crucially, how do you, as a electrical designer, as a consultant, as an installer, ensure compliance? Remember, the regulatory framework in India starts from the Act and ends at product standards. The first thing is selecting a product that meets the requirements of the product standard. That is extremely important. If you don't do this, you are not complying with the installation standard, you are not complying with the regulation, and you're not complying with the Act, right? So that is a simple case of non-compliance, and we know that not complying with not selecting product from the product standard is punishable according to the Act. Of course, we are not manufacturers, right? As a designer, as a consultant, you're not a manufacturer. How do you select a product? That is a big question that arises. The answer is you need to receive documentation from your manufacturer that to this effect. So you have to ask your manufacturer these questions. Do you design, manufacture, and verify your products according to the requirements in the relevant IEC product standards? Importantly, design, manufacture, and verification. Does your manufacturer send the product to an accredited laboratory for the purpose of conformity assessment? So it's one thing to say that your product is on your own declare, the manufacturer on their own declares that this is complying to this standard, but it's a completely different thing for a manufacturer sending it to the to a third party for purposes of conformity assessment, right? So in the case of A1, like Mr. Gandhi was telling me, they have declared conformity on their own, and it has gone to another lab, I believe, in Italy for conformity assessment to the IEC standard. It's important to ask these questions and remember any product, if we just step aside from glands, cleats, and lugs for a moment, these documents should be collated by you as an electrical designer, because if something happens down the road, your duty of care was to ensure the product selected complies with the product standard and the installation is such that they are integrated according to the installation standard. So collate these copies, make it a habit to request from manufacturers these copies. Anyways, that's the end of my presentation. um, just a moment, please. There is a mic that is, oh, somebody's mic is unmuted. So this is the end of the presentation. Of course, we are here for Q&A. So thank you. Obviously, I am here. I am an electrical installation specialist. But if you have any specific questions regarding to glands or lugs or cleats, please feel free to get with in touch with Mr. Gandhi and his team. They are very serious in terms of providing conformity. Like you said, like I said, the products are actually sent to Italy for the purposes of conformity assessment. So, anyways, any
Would you like,
questions?
Mr. Nehal, you would like to speak something?
Your mic.
Yeah.
Oh yeah.
Yeah, please go ahead.
Well, as Mr. Krish said, that selection of the proper, correct product is very important because so many incidents like short circuit and everything is happening across the India. And according to the some data from 96 to now, it has increased by almost 24%. So if we select the correct product according to the specification and is installed correctly, we can bring down this ratio and any the fatal incident to a large extent. So to any manufacturer, it is very much important, as Mr. Chris said, to check the design standards, conformity with the standards, and the test certificates, which is very important for this electrical industry. And anytime any help required, A1 Electricals is always available, definitely. If you can reach out to us anytime, any moment. So thank you all. Thanks. That's the only thing I would like to say. Thank you.
Thank you,
Yeah, we
Mr. Gandhi.
have a couple of questions. Krish, would you like to take up these questions?
Yeah, of course. I'll have to, for manufacturer specific questions, direct to Mr. Gandhi. So I'll pull him in where required.
So there is a question from Rohan Vivek. He said commercial clients do not ensure full fire safety, not complete sealing and moisture ingress. Can NFE help in push that MCT multi-cable transit, which is EPDM based civil system?
Mr. Rohan, I do not know what you mean by multi-cable transit and EPDM. Mr. Gandhi, are you aware of this?
No, actually, see, I could not see the question.
It is in the Q&A. If you just click on the more button
Commercial
there is
clients do not ensure full fire safety, not complete sealing and moisture egress.
No, it's all depends on the type of the gland selection and the required other accessory selection. Definitely, it can meet all this requirement. It all according to the application. If the correct thing and the correct RFQ is generated, like instead of the PVC shroud, one can use the LSF or LSOH shroud, and the double seal, even the seal components with the required type of the material. It gives all this. It meets all these requirements. So it is very much important that while the inquiry is generated, to mention the requirements and accordingly to make sure that yes, the correct product is being offered and is being brought.
Yeah,
Okay.
absolutely. Yeah. So, I mean,
And
sorry, can I just come in here for a sec?
yeah.
See, you have to go to the standard, which is IS 732, and figure out firstly what is the external influence. My screen is visible, right? My screen is
Yeah,
visible. Yeah.
yeah.
What is the external influence, which is there in this table? Sorry, just a second. I'll just go to that slide. This table. Once you figure out, for example, you've realized you need IP66. Now, we know that a gland that conforms to the requirements of IC 62444 has to have a minimum amount of ingress protection. Correct? And we know that is to be IP54. Now, beyond that, what you need depends on the gland. You need to talk to your manufacturer and ask them what is the level. If the gland is designed, verified, designed, manufactured, and verified to the standard, like Mr. Gandhi's, like the glands from A1, the manufacturer will provide you a declaration of conformity, and they will definitely meet the requirements that are there for ingress protection. Of course, correct installation is very, very important, and for that there needs to be communication with the manufacturer to install the product. Mr. Gandhi, please feel free to come in here.
Yeah, correct installation is extremely important with the proper accessories and everything, because many a time in India we don't use the earth tape, we don't use the shroud, we don't use the protections. So definitely you don't get the required safety and other things. So it is very important that you install it correctly with all the accessories. That is extremely important.
Okay, moving on to the next question from Manu. What is B and D in the IPXSB and IPXSD, Krish? Can you hear me, Krish? Krish, can you hear
Can
me?
you hear me? Sorry, I was muted. Can you hear me?
Yeah, I
This
can
is
hear you
very,
now.
yeah, this is a very simple question. See,
Yeah, can you be louder? Your
yeah,
voice is
yeah.
not clear.
How about now?
A little bit more.
Okay. See, when we have let me just do one thing. Let me just turn off this background noise. Is it better now?
Yeah, much better.
So when we have an IP code, there may be up to four alphanumeric. The first two are numbers, the second two are letters, but you may have a minimum of two also. The B and the D, firstly, you need to understand when the additional letter comes into the picture entirely. My screen is visible, right?
Yeah.
Yeah. The additional letter comes into the picture when your protection against access to hazardous parts is of a greater degree than your protection to access of ingress of solid foreign bodies, or there is no declared protection against access of solid foreign bodies, but there is protection against access to hazardous parts. So only protection for humans to access hazardous parts, but not dust going inside the equipment, or the protection against access to hazardous parts. So protection from humans accessing the hazardous parts is more than the protection associated for dust going inside. The B means that there is protection against access with a finger. So the test is done where you have a finger simulated, a 12 mm by 80 mm length, 12 mm diameter, 80 mm length, and it shall not be able to access any hazardous part. The D means a probe 1 millimeter diameter, 100 millimeter length cannot access any hazardous part. That is what it means. Yeah. The next question.
Okay. Thank you. Manish is why copper bus and lugs are mandatory for copper conductor. Also, copper conductors should not be terminated directly in aluminum bus bar or lugs.
Mr. Gandhi, would you like to come in here?
Yeah, see, basically it's not like it is depending on the switch gear and your conductor. If your conductor is aluminum, if the switch gear bus bar is aluminum, you can use the aluminum lugs. Same way, if your conductor is aluminum, switch gear is having the copper bus bar, you need to use the bimetallic cable lug so that palm is of copper and copper palm and the copper bus bar in the connection, and barrel is of aluminum, so it has no galvanic reactions. And same way, if the conductor is aluminum and the bus bar of the switch gear is also aluminum, you can use the aluminum lug. So it is all depending on the your connection, what is the bus bar and what is the conductor. According to that, you need to select your lugs.
Yeah, of course. I mean, there is no such thing that an aluminum conductor cannot be put on a copper bus bar. If you use a bimetallic lug like this lug and you correctly terminate it, it's not a problem. In fact, it's perfectly fine, Mr. Gandhi. Am I right?
Yeah.
Yeah.
Chris, another question from Avyaktam Swarup.
Yes.
It is seen that when outgoing cable size is AI
Aluminum. Yeah.
conductor and 25 square mm is not able to terminate, not able to be terminated in MCB of 40A. They use connection to connect
Copper cable
cable
with
with
aluminum
AA
cable.
cable. Is there any specification to these connectors which are being widely used in the panel manufacturing?
See, I am not aware of widely being used, but I can tell you what is correct. See, if you have an aluminum conductor and you're entering it, you want to terminate it on an MCB or MCCB, there are these different type of lugs depending on the kind of terminal. If it is a nut keeper terminal, you will need this kind of a product. If it is a box terminal, you will need this kind of product. And the standard for testing this is, of course, IEC 61238, and you need to identify for the dimensions what the relevant DIN standard is and then make a selection. So for example, and the tool has to be also according to that. So so there are various DIN standards and IC standards. So you need to identify which one. I don't know what is widely being used, because honestly speaking, we see a lot of poor practices being done. Stuff where a connection is not made correctly, and oftentimes, unfortunately, we see like this where an aluminum conductor is just brought in. In fact, I remember in Bangalore, I did one event with NFE, and somebody came up to me and said, in my 40 years of career, I have never heard of bimetallic lugs. So that is quite shocking. So yes, it is there. You need to, depending on the terminal, you can select either a ring type or a pin type. Mr. Gandhi, is that correct?
Yeah, very true.
Yeah. Mr. Pramod Divedi is asking, 4 type of hole lugs, where will it be used? Please confirm. I think Mr. Gandhi, you can pop in. I'll just be back in a moment.
Four-hole lugs are mainly used on the transformer side most of the time, where on the transformer side they require the 4 stud holes, and even the palm requirements is to the NEMA standards most of the times. So mainly, basically, 4-hole type lugs are always used over there. And similarly, even 2-hole lugs. 2-hole lugs, yes, many bus bar connections, there is a single cable going on, but it requires a double connection. So yeah, over there you need an extended palm, and it should have two stud holes. And it is in nowadays in many switchgear, two-hole lugs are being required, so that it gives a proper more contact surface, which is always good for the current carrying capacity.
Can you take the next question, Krish? Next question is Rankit Kumar. If possible, kindly share PPT. Yes, the video will be shared to all the registrant and the participants, so you can view the recording once again. So Pramod Dwivedi is asking, what is the criteria for selection of one hole lug, two hole lug, and four hole lugs?
I think Mr. Gandhi already mentioned that it depends on the actual application and the connection. So if there is a terminal with that many amount of nut keepers, then you
Krishna, your
can
voice is very, very feeble.
feeble. One moment.
Can't hear you. Your voice is very feeble. Like we.
Now, was it feeble throughout or just now?
No, it was just now.
Just now. One moment.
Krish,
Yeah, just a second. I'm changing my device. How about now?
yeah, much clear, much clear.
Okay. So I think, like Mr. Gandhi mentioned, it depends on the terminal. So this is not something that is standard. It depends on the application. There is no such thing that here one whole lug, here two whole lug. That's correct, Mr. Gandhi?
Yeah. It depends on the switchgear or the transformer designs, how it has been required, and according to that, we need to select the two-hole or four-hole lugs.
Correct. Next question is from Mahesh Kumar Vasure. Which type of gland is to be used for flexible cable? If we use PG gland, is this gland withstand short circuit current? If you have a flexible cable, then the gland it's not an armored cable, I'm assuming. Then there is no need for it to withstand the short circuit current, because the short circuit current comes into the aspect of the whether it is meant to form part of the protective conductor. PG is just a type of thread. Am I right, Mr. Gandhi?
Yeah, it's just a type of thread.
So normally we use metric thread, but some glands are with PG thread. It's a different thread. So yeah, if it's a flexible cable and there's no armor, then you need to just select it according to 62444 for a flexible cable. If it is for a to withstand short circuit current as part of the protective conductor, then it has to be according to that. Next question from Mr. Duraiswamy. May I know the size and standards of cables that used to connect each cable glands to the earth, please? So that has to be sized according to the requirements in 732. I'll just show you, because that is basically a protective conductor. Just give me a minute. I will just a moment. Is my screen visible now? Is the screen still visible or it's gone?
No, it's
Can
gone.
you view it? Yeah,
Now it is
it's there.
visible.
And now it's come.
Yeah. See, when you see IS 732, you need to go to which is to part 5554, earthing arrangements and protective conductors, which is on page 116. So I'll go to page 116. Just a moment. Yeah. And there is the sizing. Now, if you have protective conductor currents higher than 10 milliamps, there are separate requirements. If you are having a protective conductor, there are two ways of sizing it in general. One way is you size it according to the life conductor. So if you have up to 16 square mm life conductor, same material, use the same size. Different material, there's a K factor. If it is up between 16 and 35, you use only 16 square mm. If it is greater than 35, you use half the size. And of course, in different material, there's a factor. Alternatively, you can size it according to the short circuit current that it is expected to carry. So there are two ways of doing it. There is no specific requirement for a gland. Yeah, that regarding to the gland. Of course, there is a certain size of earth tag and the nut and bolt that will fit on the earth tag. So you need to be able to fit your conductor into that. So for example, if it's a 8 mm diameter hole, then you need to make sure that the lug you have is also 8 mm diameter hole for the nut and bolt to sit in. And then accordingly, what is the size that is there? So there are two aspects. Right? One is compatibility with the product, and the other one is just whether it's able to withstand the short circuit current. Yeah. Next question is crimping pest is required in each cable when connecting with lug. Mr. Pramod Divedi, would you like to come online and ask us what is crimping pest? Mr. Gandhi, are you aware what a crimping pest is?
Yeah, they are asking about inhibition compound. It is mainly for the aluminum. Yes, it is better to use it, but for the copper, it is not required.
Okay. Oh, he means paste. Oh,
Yeah.
okay. Yeah. Of course. There's the paste. Yeah, that is for the, as you mentioned, for bimetallic lugs. Yeah. Class 1, Class 2, and Class 6 earthing cable where to use? Sir, 1 minute. I will share my screen again. Just a moment, please. Share desktop 2. So the class 1, class 2, class 3, that class 1, class 2, class 5, class 6, that is not for earthing, that is just for cable in general. So I will just go to the page. Is the screen visible?
No, no.
No, 1 moment, please. Share. Just a second. Let me share this screen. Okay, how about now?
Yeah.
Yeah. So class 1 is a rigid conductor, solid single strand. Class 2 is a multi-stranded conductor. Class 5 is a fine stranded. Class 6 is a very fine stranded. For earthing, you can use any of these as long as the correct type of lug is used. For example, for class 5 and class 6, you need to have the correct type of bootless ferrule. Of course, in India, we recommend that we stick to class 1 or class 2 only because of the connection, the consequence of the connection and the higher resistance of class 5 and class 6 conductors. But yeah, you can use this with the correct type of lugs and terminals. So that is an important part of it. In terms of whether you can use it for earthing, again, the sizing comes again as per the Spartan 732 that I just showed. There are more questions. What type of material is recommended for cable support inside the cable box? Is it magnetic or non-magnetic material? I'm not sure what they mean. Mr. Gandhi, are you familiar?
Not much familiar, but in general, it is always good to use the non-magnetic that is advisable.
No, of course, but what does he mean by cable support inside cable box?
Cable support inside cable box, it can be even the, like what we say, cable cleats, cable glands, or any
Okay,
kind of
okay.
clamping arrangements.
Okay, in that case, of course, the non-magnetic is much better. Is what is required actually. Uh, Mr. Durai Swami is asking, earthing of cable gland to be in daisy chain or star topology and its standard, please. Well, the gland is forming part of the protective conductor. So if I go to my slides here, just a sec. Just 1 second. Let's go back to the glands, and there will be one gland here and one gland here. So it is not really star or daisy chain. It is just that there are glands wherever the connectors, wherever the cable enter an equipment, and the armor has to be utilized for the purposes of a protective conductor. Yeah. So Sunil Kumar VK, is arc flash test compulsory for cable termination? I don't see what is specific for cable termination here.
As
Mr.
far as the
Gandhi?
termination, like lugs and glands, no, it is not compulsory.
No, and now there are some new requirements in 443 for this, but there's nothing specific to the terminations in terms of the lugs and glands. Mr. Sunil Kumar VK is saying, instead of bimetallic sockets, I think he means lugs, there is a practice of using bimetallic strip between the socket and the conductor when dissimilar metals for avoiding galvanic corrosion. I don't believe this is adequate, Mr. Gandhi.
It can be adequate subject to that it has a proper, thickness and everything, proper sizing, proper selection is done. Because it's not general. People is normally what they do, they put a small copper strip and aluminum strip and they are using it, which is not correct.
Hmm. So, I mean, and there has to be a product standard, and and that has to be either tested or verified according to it. So, just you take a
Yes.
strip. I'm not aware of any IC product standard for this.
No, there is no. There is the cupel. There is the strips are there, but proper strip should be used, which is according to the palm itself. Just if you have a normal aluminum lugs, and if it is to be attached with the copper bus bar, there are the washers, but washer with a proper weight, proper thickness should be used. It is not that you can just put it anything.
Yeah, of course. But again, look, you need to, from your manufacturer, get the documents for conformity. Remember from the last slide what I said. You are, as a designer, selecting products. Collate this information. If it's not available for the product, then please do not use it. What will be the normal contact resistance between the conductor and socket when using crimping method? Any standards for crimping of sockets, Mr. Gandhi?
There are the standards. Yes, there are the standards for the crimping. And actually, I don't remember right away, but yeah, there are the standards. And if you refer to those standards and do the crimping according to the standards, it is always good.
Okay, yeah, of course. I think what you can do, this gentleman can do, I believe, Mr. Sunil Kumar, you can
Yeah,
reach out to this email here and send an email address. Mr. Gandhi can provide you further
yes,
information on this subject.
yeah, yeah.
Mr. Ravi Teja Baru is asking, should glands be of metallic or non-metallic for both armored and unarmored cable? Well, if you have an armored cable, then it has to be metallic because it is conductive. For unarmored, it is a choice for you whether you want to use metallic or non-metallic. Am I correct, Mr. Gandhi?
Very true, very true.
It's again very application specific. For HT 3-core armored cable, gland is compulsory. I mean, in general, when you enter any cable into an enclosure, you need a gland. But for HT, of course, there is a separate standard. So again, if you want more information on that, please write to Mr. Gandhi here, and he will give you more information on the spec of the HT. This is a wiping gland, I believe, right?
Yeah, it is a wiping gland. It has to be wiping gland. Yes.
So Sunil Kumar, what type of, no, this we've already answered. How, Mr. Ravi Teja Baru, how viable is it to rely on armor for earth fault protection? Does IEEE 80, IS 732, IS 30? If yes, no, sir, it is absolutely valid. If you make a proper connection, it is a great way to achieve automatic disconnection of supply. You say dedicated. This is dedicated. It is a dedicated connection. As per the product standard, the armor has a certain resistance, and it is made to withstand a certain amount of fault current. If you use the correct type of gland, you can absolutely rely on the armor to be a protective conductor. It is a dedicated protective conductor, and there is no inductive loop that is formed. There are none of these other issues. So the best thing to do is use an armored cable gland. See, oftentimes people are still scared, then they use a 5-core cable. But remember, the armor still has to be earthed either way. So an armor is perfectly fine to use as a PE conductor if the cable gland is correctly used. And you can get in touch with Mr. Gandhi. They have a variety of glands. And as I mentioned, not only are their glands tested to the standard, even the earth tags are designed for that. If we go back here, you see there are these types. Just a second here. Category A, Category B, Category C. They are tested for several kiloamperes, the gland and everything together. It is just a matter of installing correctly. And you can save a lot of money. And also, it is a peace of mind. If you run a separate GI connection, what is the resistance? Is there a product standard for that GI that is running separately? No. Only for the GI that is part of the gland that is covering under the cable standard. So absolutely, you can use an armor for a gland for a protective conductor as long as you use it with the correct gland. It is dimensionally compatible and it is dimensionally compatible. It is a dedicated PE conductor. And IS 732 perfect, there's no objection to this. Is it necessary to use petroleum jelly when doing crimping in HT and LT cable? Mr. Gandhi?
No, they are asking again about that inhibition compound, the paste, which we already answered. It is only required only for the aluminum cable. You don't require any jelly or something.
Okay. Okay. Yeah, of course. Yeah. Mr. Gandhi, you want me to show an image, is it? For on the connector strip?
Yeah, somebody just sent me this message. Actually, I'm not clear what are they trying to ask. They are just okay. They are just highlighting some this strips that is provided on the connectors here. So what exactly they want to ask on the connector strip, I'm not able to understand that what they are trying to ask.
Krish, we can't hear you.
Sorry. Yeah. As the question is, metallic can block noise. Please clarify from Mr. Ravi Teja Baru. So, please clarify. So, if you have a screened or armored cable and you use a metallic gland, then of course there is the screening or armoring is providing some blocking the noise. But just a metallic gland on an unarmored or unscreened cable is not going to do anything. Am I right, Mr. Gandhi?
Right, right.
Yeah. Somebody said I had raised the connector strip widely used in panels. Okay, Mr. Or Mrs. Avyaktam Swarup, you can please maybe write a mail to Mr. Gandhi with details and he can get back to you. Okay, I think we have come to the end of questions. I think it's been quite a fruitful webinar with a lot of audience interaction. I'm quite glad for that. So, Dominic, anything further? I think he is, yeah. Mr. Gandhi, any closing remarks?
Well,
I
only
just
thing
want
is that
to-
it has been really very good session, and yeah, just we need to be aware about what we use and is correctly selected and installed. And anything, any doubts, any clarification required, you can always reach out to us by email or on the contact details provided. We will try to help you out for your any doubts or any requirements.
Yeah, it was fantastic. We are almost 1 hour 45 minutes we have taken for this webinar, and it's quite interactive. This is very fundamental and basics that is everyone should follow and practice. It is not about company. It is about your best practices. I'm sure today's session would have enlightened the importance of determinations. So we look forward, and next week again we have a couple of webinars, and we keep coming back to you on various topics. Thank you, Mr. Gandhi and Mr. Krish. Thank you so much for spending today, though is weekend, and taken time out of your weekend and spend some time with us. Thank you so much. Look forward to see you. Please do become member of NFE. You go to our website. For all the members, there are the knowledge bank we call resource. You can visit all the webinars that we have conducted so far on various subjects. So it's a wealth of information that you'll get from NFE. Please do join NFE as a member. Thank you so much. Have a wonderful weekend. Stay safe. Thank you so much. Thank you. Bye-bye.
Thank you. Bye bye.